Everyone, this is the second EGADS Unity workshop, and today we're going to be talking about modular DOD, which is data-oriented design. And yeah, so let's get started. So I'm Kyle, I'm the Unity Workshops officer, and today it's just me since today's just a Unity workshop. So let's get started. We do have social media here at EGADS. If you came to this meeting, you probably already in the Discord. So, but links are here, and there's a QR code if you want to join. And make sure to join EGADS. It's $10. You get a T-shirt. It's pretty cool. The voting for the T-shirt design ended, so you can check out what the design is, and you can contact Ben if you want to get a T-shirt and officially join EGADS. This Saturday, there's going to be GDC Squared. This is one of the big events of the semester, and it's basically an all-day event. It's kind of like a career fair, but you're just sitting there. You can listen to talks, and then you can talk to some people in the industry. There's a QR code to join, and you can check out what talks are available, and you can just show up for those, or you can show up for the whole event. There will be food and snacks, so that's always a plus, right? Okay, and special thanks to our sponsors. They make these events possible, such as GDC Squared. A lot of them, I think all of them will be at GDC Squared. So yeah, make sure to stop by. All right, let's get started. So today we're going to be talking about modular data-oriented design. So this is a way of structuring your projects, your game projects, in a way that you can make it modular and be able to add to your projects and build upon different game mechanics that you're working on in an easier way. So let's go into it. So the official definition of DOD, it's not Department of Defense, but it is a software development paradigm that emphasizes an efficient organization, storage, and access of data in order to optimize performance and minimize computational overhead. Thank you, ChatGPT. That's how you get this definition. But what is data-oriented design? So if we're in computer science, if we're studying computer science, chances are we do know what object-oriented design is. That's the idea where you have these different classes, right? You have your classes, they have different member variables or data, and then they'll have different methods that you can use to act out different actions for your object. So for example, if you have your player class, you would maybe have like a move speed, and then you would have a move function that just implements that move speed and then moves that player, right? And that would be a more object-oriented approach. And that's kind of classically how we move our player and move our enemies inside Unity. But data-oriented design is a little bit different. So instead of having all your data and your methods all mushed together and all together in the same class, you have these bits of data, and these are going to be basically your game objects. Your game objects won't have any implementation. They'll just essentially be pieces of data that are clustered together representing whatever you're trying to represent. So you would have a player or your enemy or an object, projectile, stuff like that. And then the idea is you would have these more modular actions that you can basically use to apply some kind of action onto this data. So for example, if you have a move function, you might not want specifically a move function for a player and then for an enemy because they're all just moving. So instead, you would just have this basic move abstracted function that would basically act on your player and your enemy and just grab their little move speed data and then apply it to their transform component, right? And then you could be able to do that and just grab all the little data and kind of like a puppet master, you'll just be able to manipulate the states of these different entities. So that's the core difference between object-oriented programming and data-oriented. So this comes with a lot of benefits with how you structure your projects. So one of the biggest benefits is your memory organization. So you'll have these, for example, you'll be able to work with value types instead of pointers. How normally you would have kind of like an array of structs instead of structive arrays. That's a concept that's pretty common, especially if you're doing some lower level programming. So instead of array of structures where you have this array and then you have these different components inside, this different items inside your structs, and then your memory would be laid out something like this, right? Because arrays would have contiguous memory. So the parts that you're interested in, if you're looking for a specific part of your object, it will be all spaced out. And this produces an issue with data locality where your information isn't close together. How your computer grabs data is they grab it in chunks. So having your data all spaced together like this makes it easier and quicker for you to access certain data. So that's the back end behind what's going on with data-oriented design. Another really good thing about this method is it can allow you to more neatly organize how your objects are behaving. You can add more functionality or take away pretty easily. So we can talk about that. So that's the idea of separating your implementation from your data itself. So this brings us to modular data oriented, which is a little special. So the idea with modular data oriented design is you want to produce your code's functionality into these small little chunks that you can add and then take away, kind of like Lego blocks, where, for example, if you want to add some kind of functionality, Unity already has this where you're adding components to your game objects and you can take them away. So if you want to add a box collider or take it away, Unity already has that functionality, but this is more for our own implementations. And you can dynamically add these to your game objects and then handle them with our functionality, like we said before over here, a more abstracted functionality. Okay, so we can go over a little example because that was a little bit high level, but we can talk about how to kind of implement. So let's say we have our player's movement, right? So we'll have some kind of movement, and we really want to think about this in terms of our inputs and our outputs. So kind of some examples of input would probably be our current position, right? We want to grab where we are right now, and then we can grab some information like what keys our player pressed, our move speed, which is a scalar, and then the time that elapsed in that past frame, right? And then output, we'll probably want to send off our new position so we can actually set that to our player, and then we'll have our player movement. So it's kind of like you're passing information in and then passing it out, and that's your implementation of your functionality. So we talked about movement. It's a pretty basic way. Actually, I can show you some kind of example. For example, okay. So how Unity kind of does this, we'll go over the Okay, so this is kind of the implementation that we're looking at when we're talking about player movement. So if we go back to the slide, we'll see we want this, we want to take in some of this information, right? So what we're doing in this code over here is we're defining this player move job. And how Unity's entity component system works is you can define these different jobs that have a set that you have your standard delta time, but then you can also define your inputs and outputs. So what you would do is every component that has this transform component over here and input component and move speed component, we can look at what these are in a bit. So every component that has these three specifically will be performed, this execute will perform on those. So what is it doing? It's actually going into the transform itself and then grabbing that position And then it's applying this move speed value, right? And then times the delta time to make it frame independent. And same with rotation. So if we look at some of these over here, these are just the basic components that are default, but you can also define your own different components over here. These are the basic Unity ones. This one's the new input system. That's why it looks a little different. Yeah. Maybe look at move speed. So this one's one that I defined. You can see it's really simple. It's the most simple kind of struct you can have. It's just one value. And then the idea is it will grab this value, and then you'll be able to set that to whatever you want. And we can talk about how to set it in the editor in a bit. And so this is the idea. And you can see C# allows us these little keywords that you might become a little confused by. It's not very clear, but the ref keyword and the in keyword basically allow you to provide read or write access to these components. So in this case, we want to edit our transform, right? So we provide it with the reference to our transform, allowing us to edit. But then we don't really want to tamper with our input, and we don't really want to tamper with our move speed. So we'll provide it with in so that you can only read in the data from that. So we can read value from move speed, and we can read the current input and like the last input. Everything okay so far? We'll be able to dive deeper into how this plugs into everything else in a little bit. So yeah, that's a very basic movement use case of this. But then there's plenty of other use cases for something like this that you can apply to other situations. So for example, if you're manipulating a large data set, right? You'll have like thousands and thousands of entries. And let's say you want to select certain algorithms for you to go through and then edit. Having modular data-oriented design is pretty important because then you want to be able to have your algorithms be agnostic to whatever data you're touching. You want it to be able to swap different data sets for your algorithm to run on. And then for the same data set, you might want to swap the different algorithm you want to run it. So having this kind of modular approach is pretty important. This is also pretty good for multiplayer as well, for defining stuff that should be run on the client only, or on server only, or on both. So for example, you probably want just your input and your rendering on your client side. And then for your server side, you want your like physical controllers. So for example, your player movements, stuff like that. You want to handle that on the server side. And then stuff that you want on both is like client-side prediction. You kind of have to compare the client's position versus their position on the server. So you'll kind of need both for that. So you can just kind of be able to determine where you're running your code and then be able to modularly implement whatever behavior you want. Okay, so let's actually look into how we can implement this. I should not bring the mouse. Should be fine. So I have this really simple cube scene over here. Yeah, so my player is this cube over here. And on this player over here, I actually attached these two different authors. So let's look at what authoring are. I just named it authoring, but essentially what it's doing is it's using something that's built into Unity's package. I'll just go over the packages real quickly. So the package manager over here, the packages I'm using are entities, and it comes with entity graphics too for rendering. So this is a package called Unity ECS. So that's essentially what we discussed earlier about making these more modular um, functionality that's acting on these different um, game objects. They're called components in the system. But yeah, this is the framework we're working with, these entities, and also Unity physics. And this is just to use the physics with this package over here. So yeah, that package comes with this over here. So you can see it's part of Unity entities. And what the baker does is it runs this bake method every time you're converting into basically your Unity ECS world. So you have your regular world over here, your hierarchy, you have your camera, you have your player, you have your other game objects, right? What we actually have here as well is, make this a little bigger, is our entities hierarchy. So this is going to track what is in our scene that's managed by this entity component system. So in this case, since these have the default icon, they're not really touched, but I sort of defined this inside this little subscene over here. So everything under here is being managed by this this entity component system. So this player is actually defined as an entity inside our little entity component system world. And over here, I attached this player authoring. So what this actually does here is whenever we hit play, this will be run because we defined it as part of our ECS world. And then what it's going to do, it's going to add this move speed component and then add this player movement over here. So this is the player author. We also have another one, top authoring. And this is just another way of moving. So it's adding different components over here to our system. So authoring are basically just predefined instructions for how we're setting up our component. And this will become really clear once we. So right now, if we run it over here, actually do not, okay, there we go. That's a bug. But essentially right now we have a really simple player movement over here. We have 8 directional. And this is all defined inside our player movement. So let's take a look at that over here. So our player authoring is attaching this player move, right? So let's take a look at that. What this is actually doing is, this is you can see that this is a very simple way of implementing our movement, right? This is actually similar to our move speed that we looked at earlier, which is also a component. So we have basically just our member variables. Our game objects in this case, they're called components, but they're essentially game objects. And all they are is just a bunch of data. They're not doing anything. You don't have any methods. You don't have a move method or anything. This is just pure data. Float 3 is essentially a vector in this case. So what we're doing here actually is we have our player move system that's implemented in this world. So what it's doing is it's grabbing, oh wait, look, our player has this move input and a move speed, which we added at the start over here. So our move speed and player move input, and it has a transform by default. So what it's going through every frame, and it's going through all the components that fit this description over here, which is already cached. So it doesn't have to search through. And then it's going through and applying this to it. So we had like 1,000 different players. They would all respond to this script because they all contain these 3 components. So it's going through each frame and then adding this input and a move speed to it, and then outputting their new their new transform position. And that's essentially what's happening. Now, this isn't very interesting. It's just, we're just moving around. So what makes it very interesting here is there's also a systems tab. All this can be found, by the way, I think it's called window entities. Yeah, entities. And so our hierarchy is over here, and then your systems. This is the one we're looking at. Systems over here. So this is a lot. There's a lot here, but a lot of this is boilerplate code over here. And what we're actually interested in is our movement system. So here in our movement system, we have our hop system and our move system. So we looked at move system, but let's look at our hop system. So I think it's over here, player hop system. So this is another one of the things we added because we also have a hop authoring, which is just adding other components that are involved in the hop over here. And essentially this is just going to handle logic for kind of like a move, but then we're also hopping. So you can see over here, it's checking if it has these different properties, and then it's implementing the hop, which is, I think this was just ChatGPT. So yeah, let's take a look. So if we go over here, you can kind of enable and disable stuff. So if I disable the move system over here, so now the move system's not implementing anything, so the player should not be able to move. Yeah. If I press the keys, the player's stuck, it cannot move, and that's because it's not running through our move system because our move system is deactivated. So now our player cannot move. But if we enable this hop system over here, if we move, you'll find that we're actually hopping over here, and that we're replacing our move system with our different hop system. And you can hot swap these, so then you can just, oh, I want my move system back over here, hop system. And then now we're back to moving. And you can actually enable, the cool thing is you can actually enable both or disable both. So right now, they're both disabled, so you can't do anything at all. But if we enable both, you're actually moving and hopping. So you can see that this is kind of modular. You can add different functionality all together and then pair them together. And we'll go over some use cases with this because this is actually a really powerful thing to be able to do. Okay, so really, really cool. You can actually, you don't have to go use this editor tool to be able to manipulate this. You can actually go in inside your code logic and then manipulate this. So I kind of set up this little UI tool over here. Let's just start that. So you can see this little UI over here. We still have that bug, but yeah, so right now it's on basic movement, but if we click hop movement, now we're on hop over here. And then we can go back to basic movement over here. And what's this doing behind the hood? We can go over to our canvas here. So it's all coming from this component, and then all this is like boilerplate UI code. But over here, what's really interesting is we can just go in. World is referring to our entity component system world, and then we can just get the object that we're the system that we're working on, and enable it or disable it. And then you can do this and then toggle on and off your different systems. So for example, if you have some kind of event inside your game, some kind of you want your camera to pan around because you want to show something important in the background. You don't want the player to move. You disable the movement system. Nothing can move. So you could just focus on moving the camera and then showing whatever's behind, and your player's locked because the movement system is disabled. And if anything else that's implemented in this movement system would also be disabled as well. So all your enemies and everything can not worry about the player dying. If you have a dying system or something, you could disable that so the player's safe during the cutscene or something like that. So this is a pretty powerful way to toggle on and off systems and be able to just modularly affect your game state. So this is a very simple example. for how to do something like this. And all this code will be posted if you want to dig. Okay, so let's go back to here. All right, so we covered modular systems. This is a way of, again, toggling on and off our different systems that our objects are implemented. So we talked about entities earlier. Entities are just IDs, essentially. And they're really defined by whatever components they have. So this is where entity component system comes from, ECS, entity component system. Entities are just IDs. They're nothing more. They're just labeling. You're creating this little object in space, and it's defined. What we really define it by is what components are added to. So you can see earlier our player, it's nothing more than just the number 0. And then we define it by adding a position component and then a movement component, stuff like that. And then our systems over there, like our movement systems, are actually going in, touching that component, touching the transform, adding some speed, or adding to its transform using the speed, and then going in and manipulating those components. And then in turn, the entity is edited. That's the whole idea of entity component system. It can be a little confusing to start with, but once you grasp that concept that entities aren't real things, they're just IDs, you can kind of understand what's going on. Essentially, yeah, you're hot swapping systems. That isn't the only way for modular data-oriented design. So we talked about swapping systems, but what happens if we swap the data instead? So we have our systems, like our gravity system or some kind of movement system, and instead we switch the data it's operating. So in a sense, instead of operating on a player component, you swap it immediately to like an enemy or something like that. This gives a lot of different modular function to your project, and we can take a look at that. So essentially, you're adding and removing components from your system, having it ignore or start looking at different components. Oh, and one more thing. These systems, by the way, they're only geared to look at specific components that we define. So for example, that movement system is only looking for input and move speed and the transform and nothing else. So it's only tracking those 3. Any components with those 3 are being tracked. Everything else is being. Okay. So let's take a look over here. I have set up another scene. Actually, let me talk about the use case for something like this. So as you might know, this is League of Legends. This is a really great use case for something like modular data. So in League of Legends, you have hundreds and hundreds of champions, each one with a lot of abilities and a passive. And that's a lot of different abilities to be tracking. So if you were to go in and make one champion and then define all of its movement and all of its abilities, all in that one same component, all in Unity component, not entity component system. That's a lot of code. That's like a lot of implementation. Because you would have to define its stats and everything, all the member variables, its health, and then also its mana also, and then also each ability would need to be a method, and the abilities could perform multiple things. So it just gets really, really complicated. And this gets even more complicated when you have a lot of different champions with different abilities. And this is especially redundant when you have different abilities that could cause the same status effects. For example, like if you have a stun, you don't really need to rewrite the stun on a different champion if they're both stunning opponents. right? So this is a great way to start to implement something like modular data-oriented design. So the idea is you would have this basic abstracted stun component that would that you would be able to reuse and repurpose using some kind of stun system, and then be able to implement that with whatever champion you want. And all you would need to do is attach that to that one champion. And we'll go over the demo scene that I set up that's supposed to mimic something like this. But everyone understanding the kind of the use case with something like this? Okay. Let me see if there's any questions on this just to make sure. Nope. All right, cool. So I set up this little other scene over here. So we have a bunch of enemies, and then we have that same player over here. I turned off the hop system, so the player's just moving. And I actually added this one system over this one component. I don't know why it moved up here. But this is player authoring. That's what we were using to move it. So we have our move speed over here that we can use to edit the speed. And then also we have a player capability. So what this is doing is it's attaching this player capability input component that we defined. Let's take a look at that. And this is basically just a pretty default component that we're attaching. But what it's actually doing with our system, just system here, systems, capability system, no, spawn capability system. No. So this is what this is doing over here. Our job, essentially, whenever you see execute in here, that's how you know that's a job that's done by a system. So it's looking through, okay, does this have this this input? Does it have a transform and everything? And what it's essentially doing is going in and creating this new entity called a capability. We just called it a capability. It's not a special name or anything. And then it's spawning another object inside our entity component system world, which also consequently spawns a game object in our world too. So we can take a look. I think I bound it to space. Yeah. So you can see it's just spawning these little pellets over here. And each one of these pellets over here, you can see this is a capability. We define it as a prefab here. See, yeah, we define it as a prefab over here. So that's how we can spawn them. But essentially, we're just spawning these different capabilities. Okay. This isn't really that interesting. It's just making this little trail of capabilities behind it. But what's very interesting is these capabilities are entities of themselves that you can attach different authoring,s which will in turn attach components. And then those components are being tracked by different systems that you set. So for example, let's go in, do a bit of an example. So if we go into capabilities, this is our prefab over here. Right now we have a collision detector and this is a capability tag. This is just our system's checking it, to check this tag first for capability. So you can kind of ignore that. But for example, let's say we want like a projectile speed. So this is just these authoring,s are just definitions for how to attach these components. So once this is added to the scene, this is run once, and this component, in this case, this component is being added. So this projectile speed, which is just a value. So let's just use the default value and see what happens. Here. Oh, look, we're shooting. So in this case, we're just spawning these capabilities, just spawning this ball, and then this authoring will create that projectile speed component, which our projectile speed system, it's one of these, or it might be just the move system. It might just be move speed. Oh, move projectile system. Yeah. So it's just checking projectile speed over here. See if it applies to it, which in this case it does. So then it will just add the speed to that transform. Yeah, those balls are still there in the distance. Yeah, in this case we can just spawn. This is kind of weird that these balls just exist now. So what we can do is we can add another one, destroy on timer, right? So let's say they last for 1 second over here, maybe two over here. So now when we spawn in these balls, they disappear after 2 seconds, and then they're gone. You can see that they're gone from here. And we can do that again, and again, and again. Yeah. So yeah, that's pretty cool. We can so we could just go ahead and then add these different authoring and then just apply different abilities to our different game objects. So I wrote quite a few of them so we can play around with them. For example, this is kind of weird that we're just in our world and then after 2 seconds they just disappear. That can seem a little abrupt. So I think we can just do a little flash on timer authoring over here. I think that's fine. So what this does is it provides a little timer and then disappears. And then just to give us a little indicator as it's about to disappear. And that's just grabbing the amount of time left from this timer and then flashing accordingly. So if we were to change that to 4 or something, then you can see it's scaling accordingly. 4 seconds. And we can do even more with stuff like this. You can add even more functionality, stuff like this. So spawn on destroy. Wait, I also made a spawn on destroy authoring over here. I already defined it. Explosion is another prefab that I defined that has different authoring that I already preset. So we can just take a look at that. And what this does over here, let's see. After 4 seconds, it just does a little explosion. That's pretty cool. I think, yeah, so you can just add these different functionalities to whatever you're doing. I think I also added the capability to, oh yeah. So I can just do contact, destroy on collision. So now whenever it collides with anything like this, it's going to destroy itself. And on destroy, it's going to spawn that explosion, which is pretty cool. So I'm just going. And it's pretty cool. It damages it, and it does 5 damage to all the different cubes inside our area. So, and that's because our cubes already, those enemies, I put an enemy authoring which tracks it's kind of like a damage system where it can track if something's damaging. So I called it damage buffer element over here. So yeah, you can kind of like mix and match these kind of things. And then you can also take away capabilities as well. So for example, let's go into our capability over here. Let's say I don't really want this to move anymore. That's kind of weird. Let's just go in, remove this projectile speed. And then let's see what happens. So when we go here, we can do a little space, and then now we have kind of like a landmine. We're here, and then we just go ahead and then boom, and then do damage like this. So you can kind of toggle different abilities for whatever game objects or entities that you have, and then mix and match kind of their capabilities, add different functionality, take it away. This is pretty cool for a game design standpoint, where if you want to buff or nerf a different character or something, you could just quickly drag and drop at it. And you would still need to write the system is that you're implementing it. So all these different systems I went ahead and wrote early before this. But when it comes to after you implement everything and make sure everything works, it's pretty easy from a design standpoint to just go ahead and then kind of mold your different abilities for your um, characters. Yeah. So yeah, any questions? All right. I think this is pretty cool. So yeah, with that kind of design approach, you can attach like different abilities, and you can have shared abilities among your different champions, but also allows you to overhaul different systems if you really need to change a big system. So, for example, if you want to change how cleanses work, for some reason you don't want like you want to cleanse everything except for slows for some reason. Like you think you should be able to cleanse stuns and everything, but if someone slows you down, you should keep that slow. Then you would be able to go into your cleansing system and then ignore that status effect of being slowed, and then you can go ahead and rework that, and then it would apply to every single champion that when they use a cleanse ability. Okay, so this all seems really great. Um, this seems like it allows us to build these really huge games and with a lot of potential to add and remove capabilities to make something really be able to adapt to whatever design changes that we need to do make down the road according to player feedback. And this isn't only for design as well. You can actually expose, kind of like we exposed that UI with the hop and the movement. You can actually expose stuff like that to the player in kind of like a skill tree or something. And you can start adding capabilities to your different game objects or remove them and as kind of a nerf to whatever player you're doing and expose that to the player. But there are some cons to note for stuff like this. It actually ends up generating a lot of small little scripts, as you might have noticed. I think the shortest one was like that one liner. It was just one value for a struct, which kind of defeats it. It's kind of weird to look at. Um, in this little demo, there was literally two scenes over here. I had like 50 plus scripts, which is it can be tough to sort through all this. You could see me earlier trying to find stuff, and this is just two little scenes. So that is something to note. You would have to really organize um, how you're working and making sure you're not losing functionality into a big code base. Another thing is behaviors might not play nice with each other. So how the systems work is they go through one entity, one set of components, and then one set of components, and then one set of components. And then you have your next system work with your next set of components and the next set of components. Uh, but if you're setting like the transform to something, and then you have another component setting the transform to something else, it could really override what you're working with on the other one. So you have to make sure you're kind of like editing the value and not really resetting the value unless that's your intention, which is to like reset the velocity to zero no matter or something. But behaviors like that could interfere with each other. So you do really need to test and make sure, even though they're a modular in theory, that they actually work. And that is pretty much it for data-oriented design. Yeah, thank you. Yeah, on Zoom, let me know if you have any questions. You can send me in the chat, or you can just, yeah, you can send it in the chat if you have questions. But yeah, if you have no more questions, I'll let you guys go. Mhm. I'll be sharing I'll be sending the code in the Discord. So if you want to check it out, and I'll also send the slides too. Oh yeah, yeah. Someone asked if there's any resources for learning about data-oriented design. So I think Unity has website. Unity, I think talking about Unity ECS. Still showing. Um, um, Unity ECS. They have pretty extensive documentation on it. Um, yeah, and they have a getting started. A lot of my code here was um, from the documentation up there. Not the abilities themselves, but the boilerplate for setting up that kind of systems uh, setup. There's also a book on data oriented design. I forgot what it was. It might just be about. No, that's not it. I'll let you know if once I find it again. It's a pretty good book. I forgot the name, but yeah, I can send that in this. Mhm. Mhm. I've only interned at one company, so I don't really know everywhere what they do. But um, we didn't use Unity ECS, but we did use dependency injection, which is kind of another model that I can talk about some other time. Um, but yeah, we did not use Unity ECS. This is actually pretty new. They're coming up with an update this year to improve it. This came out last year, so yeah, all this is relatively new stuff. Maybe 2 years, maybe 2 years. I think yeah, end of 2022. That's when the whole Unity ECS system came out. Yeah, you definitely can use for smaller projects. I definitely recommend you just for game jams just use regular game objects and then add components and just do normal Unity stuff. But I would say if you have a game that has a lot of different game objects with a lot of different abilities, I would highly suggest looking into something like this to really organize um, and just also be able to approach making your game uh, with a more fluid way of handling issues and adding features. Yeah, especially if you think you might reuse a lot of the common abilities. Um, yeah, for like example, like Factorio or something when you're moving, um, like a system for taking in an item and then sending out an item, something like that. That can be pretty modular. That, but then sometimes you want to send out two items while taking in one. So that's stuff that's modular but has a similar functionality. I would say this kind of system really lends itself to. Of course, Factorio didn't use that, but yeah. Let me just, I'll stop it.